All right. In the last episode, I added some particles to my game, a particle system of sorts that spawns these kinda, I guess, some dust for atmosphere, right? And also when I walk, there's this footstep effect, basically, that shoots up some kind of dirt or mud, right? And this is just a test effect, but it looks pretty cool, right? So that's what I did last time, and these particles also interact with my kind of player vortex here, so I can kind of interact with them, but they are purely visual. Yeah, right. And I thought today there are some pretty annoying things going on with the player physics. For example, when I walk to the left here, I get completely stuck in the ground, which sucks. So I thought I would debug that today. There's obviously something wrong here with the collision code. And I think a good place to start is by drawing what we're actually colliding against. So right now the world is created out of this polygon thingy, right, that I can edit, and that's converted into triangles by an algorithm, and then I collide against those triangles. So I can draw those triangles here to kinda, I guess, get a better idea of what might be happening when I try to walk up this slope, right? So I get stuck on this vertex. The player seems to be following one of these triangles for some reason, and I think I might know what's going on. The collision code is very rudimentary. So let's see how that's working right now. And I think there's also some debug drawing I can enable to try to visualize what's happening there in the algorithm. So let's see. So we're doing some kind of collision detection. Let's see. And then we try to push out the player right out of the ground, basically, if it's colliding. Right. So I think we can debug draw these two things. Apparently not. Where is this? This is in game tick. Okay, what's... I assume there's something... Let's see. Yeah, the debug renderer is not enabled or activated yet in the frame. Let's see. Here, okay. I like set this global debug renderer state, right? Because my functions, I don't want to pass the debug renderer everywhere, because that would be pretty annoying on the color side, right? So I have this global debug renderer. Right, so I just have to do that earlier, and I think there's not going to be any issues with that, really. Right. I just haven't done any debug rendering inside of the tick functions yet. Alright, so that's fine. So let's see if it's drawing something. Right, that doesn't really show much, but let's take a look at the debug, or at the collision code. And what are we doing? So this is running for every triangle, right? And I think we're checking for every corner of the player bounding box. We're checking if it's inside of the triangle. Yeah, this has collision, right? So if a point is inside of the triangle, we try to find the point where we should... where we should push it out. It's kind of hard to debug this kind of stuff, because it happens so fast, right? But let's see. I think there is a big problem, kinda. So let's see. The way we are determining in which direction to push out the player, I think that's kinda broken. We should basically always push it out towards the player right now. But right now it's determined by which plane of the triangle, or which edge of the triangle is closest to this intersection point, right? So in this case it's working, because this big edge is definitely closer than these two to this point. But it gets a bit tricky as I walk here. So the closest edge becomes this one, right? It becomes this one. Because as I'm walking left, I'm basically pushing the player into this floor, right? And eventually the closest one becomes this, and it tries to push it out so that the edge lies on this edge, like, right? So that's wrong. I think I can change the logic pretty easily. So I guess instead I should just choose the edge depending on... we could like check the center of the player, right? The center of mass, kinda. I think that should be a pretty simple change. Maybe. I wonder. Oop. I guess I could try that. That's, I think, at least gonna work for this situation. Or I think maybe... let's see if we can do some better debug drawing, maybe. So if we have a collision, right, we check the closest edge. So let's instead, if we have a collision, I think first of all we can try... I mean, this is... Yeah, let's try to, instead of just drawing the I'm actually thinking more and more, like something I thought about earlier is that why are we even colliding against triangles? Because we have this, the world is like a polygon, right? Why can't we should just collide against that instead? I don't think we have to care about triangles at all. Maybe I should try that. I think that makes more sense. I think that makes more sense than trying to triangulate it right first and then collide against the triangles. So let's try that. I feel like that should be a lot easier. Right. So I guess the first step of that would be to actually, instead of returning a list of triangles here from the world, I guess we should just return the polygon itself. Yeah, I mean it will be exactly the same as this world edit info, basically. Let's try that. I think that makes a lot more sense, actually. Right. So let's take in the same data here. We have some number of polygons. Right now that's 1 in the whole world. And the polygon, yeah. And the polygon has some vertices. Let's try to pass those. That's exactly the same as that, and I guess that's it, right? So right now we can try deleting this whole code. Right. So now we should have no collision at all. Yeah, we're falling through the ground. Perfect. So let's try the alternative here. To collide directly with the edges of the polygon. Right. So we take the first polygon, and we're assuming that there's only a single one right now, because there is only a single one. So let's assert that. In case we add more in future, right? So let's just take a reference to this polygon. Actually, first, I want to have the game running. Because you see it, I mean, above my face cam, right? It's something nice to look at, I guess, while I do this shit. Right. So for the polygon, we have some set of edges, right? So how we find those edges is just going through every vertex, right? And the polygon has a vertex count, yeah. So we go through every vertex, and we also have to get the next vertex index, right? Which is the vertex index +1. Because the vertices are ordered in a clockwise direction, so the next vertex is always like the next. Well, I don't know. It's just how it's defined. I don't know how to explain it better than that. It is what it is. Okay, so we have to wrap that around, because if we are at the last vertex, the next one is the first one in the whole polygon, right? So we have those two vertices, and we can pull out the actual positions. Let's call that A and B. So we have vertex A and B that make up this polygon, right? And we probably want the normal, which is pretty easy to figure out. It's just this. No, wait, never mind. First I want the vector that goes from A to B, so let's call it AB, right? Like in mathematics. And to get that we subtract B from A, right? I think that's the right direction, right? So that's vector AB. And we should have a normalized version of that also. We're gonna need that. So that's basically, I guess, that's like the tangent, right? Basically. If we normalize the AB vector, that's a tangent. Okay, and the normal is this. It's a tangent like that. Right. We did something very, very similar. We have this level editing, right? And okay, right now it's not visible, but we basically figured out a way of finding the closest edge to my mouse, not the closest vertex. That's pretty simple, right? But figuring out the closest edge is a bit more involved, and I think we want to do the exact same thing, basically. So for our player, I should disable this debug rendering, because I'm using the same debug rendering to actually highlight this edge. Right. Oh, it's a bit difficult to see, probably. Maybe it's not what we want either, maybe. But something similar. So if I have my mouse here, we highlight the closest edge if I hold shift, and I can like click to add a new vertex on that edge, right? I feel like we want something similar. So if we figure out the closest edge, it should be pretty easy to just collide against it. Right. Let's try that. So we have the normal and the tangent. I could actually check this code, right? So at the closest edge, we figured that out somehow. So what we're basically doing, it would be nice to have some nice paint program actually, so I can draw stuff. But let's see. well, first, we need some point to check, and we're gonna check every corner of the player's bounding box. Right. What is this corners? Right. Okay, let's just steal that from my other code. So we have each corner of the player bounding box right here. So somewhere we have to do some loop. And I wonder if that should be the outer loop or the inner loop. For now, actually, let's just take the first one and let's ignore that, because it's gonna work, right, if I just pick some random point. So let's care about that later. So let's call it corner. Right, instead of the mouse position, like the editor code. And I wonder if there's some nice way to visualize all of this. We can draw a debug line. From the center of the edge. To this basically projected point, right? So center plus tangent times the tangent distance. So now we should see some lines. I guess the problem is that the player is falling to the ground. Let's change the gravity to 0. Right. Why is it blinking? Oh, it's blinking because, right, I have a fixed tick rate, and I guess some frames there just isn't a tick, right? That's pretty annoying. I'm guessing OBS is like missing this also. Yeah, it's hard to see. So how do I fix that? I could just ensure that we do a tick. Oh, that's an unforeseen problem. Let me think. I guess we can just slow down the rendering, right? Is there any way to just sleep? Yes, in seconds. Is there like a faster sleep? Linux sleep milliseconds. Nano sleep. Right. Sure, let's try that. But that's a bit annoying. I wonder how I should solve that for real, right? I... And like if we have multiple ticks in one frame, like we're gonna see multiple debug lines as well, right? And that's not preferable either. So maybe I mean the real solution might be to do the debug drawing in a outside of the tick, but that also like then I have to recompute the collision stuff, right? Because I want to debug render this inside of the tick. I guess I could save some state. I guess I could save some state while I'm doing the algorithm, right? And debug draw that state instead. Basically capture it, right? That feels a bit silly. Feels a bit silly. But it feels more silly to sleep. But I will do that. I will do that. Nano sleep. Right, so how long should we sleep? So we have the nanoseconds, and how much is that even? So if we have 1,000 nanoseconds, that is 1 microsecond, right? And if we have 1 million, let's do it like this. That's correct, right? 1,000 times 1,000 is 1 million. Yes, yes. So that would be one millisecond, right? So let's say that we just sleep for 20 milliseconds. Sure. Nano sleep, implicit time H. Do I not have that? Is this like some... do I need to set some like POSIX version or what? Yes. And I guess I haven't. Oh my god. Wait, do I already? Do I just add this? Let's see what happens. Yeah, I'm building main here with this flag, right? What's okay? This. Wait, am I supposed to define this myself? Maybe it's like defined here. No. It seems like I should define it myself, right? Well, or if okay, I don't even. Okay, this feels stupid anyway. Okay, just give me some fucking way to. Jesus. Jesus. Okay, you sleep. sleep. So that's microseconds, right? Thank you. No. Okay, how can I check my glibc version somehow easily? Well, okay, uni stood. Okay, I have it included. Okay, so it's probably this, right? So you sleep. This is ridiculous. So what? Do I have to like set this? Like that, or what? Macro names must be identifiers. Okay, I mean, okay. Fuck this, just do it here, I guess. But like... Did I... Okay, I'm fucking stupid. Okay, there was a different... Okay, thanks. Thank you, God. Okay. Okay, never mind. I don't actually... Now I should have you sleep. No, I don't. I don't. Feature test macros allow the programmer to control the definitions that are exposed by system header files when a program is compiled. In order to be effective, a feature test macro must be defined before including any header files. This can be done either in the command, in the compilation command, which I am doing. Wait, no. Okay, I'm not. I changed the wrong one, right? I changed the wrong one. And it shouldn't even be required here, right? Because I'm just compiling objects. Yeah, this should be the only place. Okay, let's try that. POSIX C source redefined. Okay, I am actually defining this somewhere else. Okay, then I guess, okay, which is the greater one? Which is the greater one? Yeah, this one is the larger. Let's do that then. That should work, right? I still don't have you sleep. And it wasn't even in timing. Unit stood. So, okay, where did I get that from? Stack Overflow. Well, no. Oh my god, okay. Oh my god, I can just do select on nothing. I can do select on nothing. Okay, let's do that. That's more cursed. Did I remove the sleep? Okay, that's really cursed. But it should work, right? Just an empty select. I love it. Where is select, though? What header is that? I'm gonna assume select. It's like sys select, yes. Okay. Passing, blah blah blah, okay. It shouldn't be const, apparently. Are you gonna modify my... Wait, should it be? What's the problem? What's the problem? It's a time val, okay. Time val. Not a time spec. Okay, what's the difference? What's the difference? Okay, so USEC. So this is microseconds. Okay. So let's sleep for 20,000 microseconds. 20 milliseconds. Okay, please. Okay, thank you. Okay, thank you. Okay, so I slowed down my game enough so that we can see the debug lines. Okay, perfect. I love it. Extremely cursed way of sleeping. Right. So we have this tangent distance, which, with taking the absolute, it's nicer if we don't do that. Just for the debug drawing, right? So we can do it when doing this comparison, right? Sure. However, yeah. So what we're doing, I guess we're using this this bottom left vertex to do all of this debug rendering with right now. So what we're doing is for each edge of this polygon, we are projecting it basically onto each one of these edges, right? So you can see that the projection, we're basically casting a shadow, right, of the point. If you imagine that there's a sun that's shining exactly perpendicular to the plane, right, and it's casting this shadow. So this point is being cast here. So you can see that being visualized here, right? And it's the same for every single point here. So it's being cast down here, right? And using this, I think maybe the next sensible thing would be to... I guess let's see what happens if I just basically clamp this distance, right, to yeah, we can use some like a debug tangent distance, which will be the tangent distance. However, if this distance is larger than half of the edge length, we just oh, hold up, we have to check the absolute value, right? If the absolute value is greater than this, then we just assign it to this. However, we want to maintain the sign, right? So how should we do that? There is like a way to get the sign, right? Sign bit, is that it? Sign bit. Sign bit. Get floating point sign. Alright, we want to get a sign out of this float. Get float sign as. I wanted that like so I can just do a multiplication with it. So like I want it to be either 1 if it's positive or -1 if it's negative, right? I'm pretty sure there is something like this. Ooh. Okay, I mean, okay, I can just do my own, right? It should be easy. Should be easy enough. Okay, so let's just have something like sign F sign. No sign. No F sign. There is probably a better name here, but whatever. And yeah, X. Okay. So greater equals doesn't really matter. Okay, return 1. Right. Okay. Like that. Let's see what happens. Right, we are still using this tangent distance for the debug rendering. Alright, so this looks sensible. So now we're just clamping it to this edge here. And we can actually I actually wonder. Is this just enough? Can I just find it? Oh, hello. What books for C++ Advanced do you recommend? I don't think I can recommend any C++ books. I haven't read any myself. Not really. I read like one book. I don't really read books, unfortunately. Sorry. I've only read like one book on game engine architecture. So let me think. So I guess we have some projected point now on this edge, right? So and we know where that is into this space, right? So I think I should start. I can just start by just drawing this point, and I already have it here, right? From the drawing the line. So let's draw debug point, right? So if I do that, right, we have some points, and I feel like now figuring out which, because these edges, they're basically planes, right? So if I now just compare the distance from every single one of these points to the vertex of my bounding box, then that should be the closest plane. And I think it makes sense to just do the collision against that plane. Right. That feels simple enough. So let's see. I guess this shouldn't be called... Well, let's call that clamped. Clamped tangent distance. Sure. Alright, so we have this point now, and I guess all we have to do is just check the distance, right? So I guess let's first just resolve this point into some variable, and what can we call that? Let's call that projected, maybe. Projected corner. Yeah, that makes sense. So, I mean, we already have that in this debug rendering, right? But we can probably... Right, we can do it with our vector math instructions, right? So we want to add the center of the edge with the scaled tangent. And we want to scale the tangent by this clamped distance. Right. And we can use that for the debug drawing now and see if it makes sense. Yeah, it's still the same. Right. Right, so now we can just measure the distance between the corner and the projected corner. Right. That's the distance. And I guess we want to keep track of which edge that is and do something with it later, right? We can do that. So we have the closest distance, right? Which is, let's initialize that to the max float. Oh, that's, and we have the closest edge, right? And we can set that to 0, even though it shouldn't be needed. And if the distance is closer than the currently closest distance we found, we update it. And the closest edge, we'll say that that is the vertex index, right? So it's the vertex index of vertex 0 of the edge, right? This A, right? So then when we're out of here, we know which edge was the closest one. And now what? I think we just want to... let's see. Oh, I didn't close... my GPU almost died again, once again. Right, but if we have the closest edge, right, it's trivial to compute the position, like I guess where we want the vertex to be, or where we want the corner to be, right? So in this case, wait, the position is just, it is this projected position, right? We don't have to do anything extra. Is it that simple? all we have to do, I guess, is to check whether we are inside of the polygon, right? And that is a plain test. That's a plain test, and I'm gonna steal that from the editor code. Yeah, it's this. This is a plain test, right? So let's see how we would use that. So we now have a closest edge, and I really wonder. I wonder. We're gonna have to recalculate a bunch of this stuff, right? But maybe we can just store it, maybe. So we want to know the normal of the closest edge, right? Let's see, and we need some point. We need point A. Let's just see. Let's see. So we need point A. So we have the closest edge. Use that to find the vertex, like that. And we need a normal. So I guess let's just recompute that. Let's just do that. Sure. So we need B as well. Let's see what happens. Do I actually do anything? No, I don't do anything. Maybe I should debug draw this, maybe. And this should not be the absolute. So the way that we know, we should check the sign of this, right? So if this is negative, that means that we are inside of the polygon. Well, behind the plane. If the normal is pointing outwards, right? So if it's negative, we are, in fact, inside of the polygon. And what should we do then? Well, we have this projected point, right? This projected corner. I feel like we should just push it out there. So let's save that, actually. We'll have some closest project, that's too long. Closest push out, maybe. Sure, let's save that. So we have the projected corner, right? So if that's the case, we just move the point there, right? What does that mean? We have to move the player, right? Well, we can do that here. We want some vector that points from the corner to this projected corner, right? So that's just a subtraction, like that. And then we have to take the player position and just move it by this push out thingy. Right. Let's see. Alright, seems to be working, right? seems to be working. Okay, let's try to add back gravity. Did I accidentally? No. I thought I removed something else. What the fuck? What the hell? Oh, I think I know. I think I know. If we actually hit the ground, right? We have to, or we want to, reset the velocity. Yeah, because the velocity is constantly being pushed down, right, by gravity, and at some point I think it became so big that we just phased through the ground. But let's just reset that. Reset the velocity to 0. Okay, I like that. I like that very much. It's already working better than what we had before. And we also have this flag, right? If we are grounded, so I can actually jump. Right. Okay, that's working. Nice. One kinda maybe annoying thing is that when I walk uphill, my movement speed is actually reduced. Right, if I walk up this steep hill, I'm moving really slowly. Right, and maybe that's good. Actually, I don't know. Maybe it's good actually, because otherwise you would, I guess, move really fast, like vertically, right? Let's try to make a very steep hill actually, just to try this. That should be fun. Something like this. I really wonder what's gonna happen. I mean, in this case, the player should just walk up it, I guess. Maybe. Yes. Yes. Okay, that's... it's more robust than I would have expected, which is nice. And in this case, actually, I guess, yeah, here it's extremely steep here, so the gravity is pushing me down faster than I can actually move up this hill. But I can still jump. So if I jump, yeah. I probably have to figure out how to do that, because I don't feel like that should be possible to just jump up here, right? Maybe I need some kind of different condition to check whether I can jump, right? Maybe there should be some maximum slope or something like that. If it's too steep, then maybe I shouldn't be able to jump. I'm not sure. Right, but there's an obvious problem right now, right? I'm only colliding against this this bottom left corner of the player, right? It's really obvious here, right? So I guess I just have to go through every corner and do this collision. And a potential issue I can foresee already is like, what about this case, right? Or I can make an even more extreme case, actually. What about this case, right? Like, is my code gonna be able to correctly resolve this? Right, because I'd want to basically be still here, right? And I wonder how I want to resolve that. Like, there's gonna be multiple intersection points, right? And the question is how to handle that, like, correctly, right? I can see, like, if I do a simple solution, like, I would select, like, each tick, I would, like, select one of the corners, right, to do the actual collision resolution, right? But then the player is gonna shake a lot if multiple corners actually are colliding with this polygon. But we can try that. So I guess if we test every corner, I will somehow judge, I guess, which corner is the most important collision to resolve, right? So maybe I'll check the how far in it is, something like that. Yeah, I think that's gonna be simplest to do. So we will still choose some corner and resolve the collision for that corner, right? Right, and I think the player's gonna shake a lot, probably, most likely. But we'll see how that works. So right now, I just picked this corner, right? So I will just go through every corner using the corner index. There are 4 corners. Actually, what happens if I just run this code for every corner? That's gonna be interesting. Let's see what happens. I mean, it works, right? However, let me try this extreme case again. I did actually save the world. Okay, so yeah, let's make a pit and see what happens if I jump down. It's really stable. I guess that's because it's oh shit. Oh my god. Okay, something is happening here. Oh my god. Okay. Okay. That's pretty strange. So it like right here. Oh, here also. What the hell? Okay. That's interesting. I'm like being teleported. I'm being teleported back. Okay. Okay. That's pretty weird. Oh, I think I might... wait. So there's something that happens, I guess, when... Oops. Let me... Okay, I'm there. Okay, so let me try to make like a steep, a sharp point like this. Right. So something weird is going on here. And I think it might... Something very weird is going on here. And... oh, I think I see some potential issue, right? So we're just picking the closest projected point. Right. Let me try to... okay, I can't jump past this point. It's over. Okay. Oh. Okay. What could the problem be here? I mean, I can see something like at this point, right? There are going to be, there will be, like these two edges, they will have the exact, like which one is gonna get picked is completely ambiguous. Let me think. Okay, so why would that be a problem? Right. So if I'm above this point, right, these two edges will have the exact same distance. And right, and that's not good, right? Because I have to prioritize one of them depending on... Okay. But why is it working so well in this case? What's really different, right? I guess as soon as... is it as soon as I have some corner that's like steeper than 90 degrees? Is that the problem? Okay, so this seems fine still. So let's try to push it. That's like exactly 90 degrees probably. That's working. Okay, so if I do it a bit more, it should break, I think. Yeah, okay, it breaks. So what is the problem here? I guess the difference, basically, is that we have two planes here, right? We have two planes. And I guess in the case where it's less than 90 degrees, right, it doesn't matter which plane I pick, right? It doesn't matter. Because if my corner is here... Wait, why doesn't it matter? Why does it break when the pointy point is sharper than 90 degrees? I wonder what debug visualization I could add to debug this better. Right. Like I have some idea, I think, but why 90 degrees? I'm trying to conceptualize what the difference is, right? What's the difference? If I make this sharp, like what is the difference? So it seems what even seems to be happening, right? So I walk up and I teleport. What could does this still happen if I only check a single corner? Does it still happen? Let's build some geometry here. Alright, so that's sharper than whatever. It feels like that's working. Feels like that's working. And now I'm thinking, so if my point is up here, does it matter which plane I check? I think the answer is no, right? Because the answer is no, because the planes, because in this area it doesn't intersect any of the planes. However, if I'm here, but it's still I wonder, I need some way to pause. I feel like I need some better way of setting this point so I can like really visualize what's happening. Because if I'm below, it's still ambiguous here, right? Like the same. Okay, there is some strange stuff going. Yeah. Right. Okay, so how do I solve this? Because, okay, so my condition, right, is my condition of selecting this plane is checking which is closer to the vertex I want to test, right? And that those 2 points they're the same distance. They're the same distance, so it's completely ambiguous which one will get tested, right? So right now it's in it's in the order, clockwise order. So in this case, this edge gets tested completely arbitrarily, like when I'm on the right side. But if I'm on the right side of the spike, right, I want to select this plane, but I'm thinking why? Because I don't want to do that. I don't want to do that always, but I wonder what the condition should be. What should the condition be? So it's not enough to just clamp this point and check the distance, right? So what should I do? Like, it's kind of obvious in my head. Like, if I'm to the right, how should I rank these two planes, right? That's the question. Right. So in this, it's strange that it doesn't mess up in this case. Oh, well, I guess it maybe it isn't, right? Because these planes are so similar. Like, it works here as well because... Alright, so what's happening, I guess, if we cross 90 degrees... If we cross a 90-degree angle... I guess the difference... Right, the difference is that, okay, if it crosses 90 degrees, if it's sharper, then there is some point, at which the distances are equal, and at that same point, one of the planes is behind the point, right? So I guess... Do I just check that? I mean, that seems pretty silly, but okay, so let's say there is some condition, right, where I have two. Is it only two also, by the way? But there is some situation where I have two planes. Like, checking the distance is not enough, right? So I guess I can detect that case by checking if these two consecutive projected points are equal. Right. Okay. So do I need to check? Let me think. So we need to detect multiple closest points, basically. But we know that they're gonna be equal. So we check this condition here, right? If we are closer than the current closest point, right? And let's say that if we are not, if we are instead exactly at the closest distance, that means we have this ambiguous case, I think. And what should we do in that situation? What I'm thinking is that in this case it makes sense Wait. Okay, I'm thinking really hard right now. So let me make this more extreme. Right, so what's happening? We are selecting this plane and we are to the right, which means that we are technically inside of the plane, which means that this collision thingy is going to resolve us to this edge, right? Which we want to avoid. And how do we avoid that? Well, wait, does it also work the opposite? Alright, oh god, it works the other way around as well. Okay, why is this so difficult? Maybe my first... Maybe just my way of figuring out. Well, wait. Is there some easy... Because I guess... What I want to find out, I guess, because... Wait. So what's my... Right, it's not enough to just find the closest, because it doesn't that doesn't matter, right? If yeah, okay, there's something wrong here. Can't I just... Is there some trivial way to figure out whether I'm inside of the polygon first? I wonder if that's gonna solve it even. Okay, so it's not really a problem with testing the multiple corners, at least. I've deduced that. It's something more fundamental. Okay, let's add this this broken case, and let's save the world also. So we'll save it now. And I wonder if there's an easier... let's try to make it like angled like this, and let's see what happens now. So if I don't know if that's easier. Okay, but let's make a pointy thingy, right? Okay, so what is... okay, and let's try with 1 point, because it's gonna be impossible to like actually visualize this otherwise. All right, so I am... yeah, my logic is just flawed, right? I think. I'm pretty sure. So, what do we actually want to do. Okay, and checking, is it trivial? Is it trivial to check whether we are inside of the polygon? I mean, it's like it's kind of combined, right? We want to do that. And like it works in this case, it works in this case. So is this just some edge case that I have to solve, right? Or do I have to change something more, my algorithm more fundamentally? Now it's not bugging out. Do I have to make it more drastic? Right. Now it's bugging out. Right. So how should I actually find out what I'm colliding against? Right, so what's happening is this plane gets... okay, I think I need to change something fundamental. Okay, but I'm kind of stuck here. So how should I actually debug this, right? Or maybe I just have to think about it a bunch, a bit. So I guess the fundamental problem is to figure out if I'm inside of the polygon at all. And I can kinda like see a way of doing that, right? I mean, basically, I guess we have this clamped tangent, isn't it? Okay, so what if I just actually reject the points that get clamped, right? So let's say if this gets clamped, and let's do that before actually. So we want to check this. However, if this condition succeeds, right, instead of clamping it, let's just continue this loop. Essentially just skipping this stuff, right? So then we also want to check, because I think it's possible now that we don't find a closest edge. So let's just say that if it's not, we use float max, right? So that means we actually found a closest edge, a valid one. Right. That is interesting. Right. And I kind of suspected... something like this. So I guess now what's happening is that on the corners, if I don't like face through the world, I guess it's not even safe if I try to jump. Right. So with this concave, or what's it called? Yeah, this Okay, never mind. Nowhere is safe, apparently. There now is the case. Okay, I'm trying to figure out, like, there's some case now where, I guess there's some, like, edge case, like, where we don't, where neither of the projected points of these connecting edges, where it doesn't find any. Right, I think I see what's happening. So we can't do this because that's actually I need to get some kind of image editor. Yeah, what? Did it? Pinto. Let's try this. Oh god, it's like GIMP, right? With multiple windows. Oh god. Okay, so what's happening now? I can't just... How can this be so difficult? Surely this is... I mean... I kind of saw this in... So if we go to... box to the light, right? Well, maybe. Did they have... Okay, right. Box to the light only has boxes. Right. But the real box 2D has polygon shapes. Let's see what they are doing. Right. So they had some function, if I can find it. Um, mm, mm, mm. Here, right. B2 collide polygons, okay. Find edge normal of max separation on A. Okay. Okay. So a polygon shape is a set of vertices, and I assume it's like the same, right? Like it's a polygon defined by a set of vertices, and there's some winding order, right? That defines the shape. Right, and there's a centroid. Also, maybe that's necessary. Right, so let's see what happens. And the manifold is the result. So the manifold is a list, right? A list of contact points. Right, makes sense. Makes sense. Right. And wait, what was there? A local normal. Okay, so the normal. Okay, so there's multiple points, but there's not a normal for each point. Okay, interesting. Find max separation. Find max separation. Find the max separation between poly 1 and poly 2 using edge normals from poly 1. So there are normals also for each vertex. Okay. In my case, that's implicit, right? Oh, and oh, right. Well, wait. Right, the way I saw let's look at the B2 shape, the polygon shape, right? So you can make a box. You can create a polygon shape that is a box, right? So 4 vertices. That makes sense, right? Okay, so this makes sense. So I think it's kind of the same way as I'm doing it. So we start at top left, and we go towards the right. So this is the top edge, right? These 2 vertices represent the top edge. Yeah, if we assume that y is negative y is up, right? Let's say that negative y is up, right? And this is the normal of the edge, right? That makes sense. So instead of just what's it called? Instead of just implicitly defining the normal by the 2 points, they have it here for some reason, right? Right. So the normal is the normal of the edge. All right. So the max separation.
resist aggressive impulses results in serious destructive acts. People who commit these acts are
We go through every vertex in the first polygon.
They disassociate themselves from their own actions, often experiencing hysterical blindness. They're blind to the darkness within themselves.
Right, and this we don't have to care about.
The darkness within themselves.
So the max... So they want the max. Why do they want the max separation? So they want... Yeah, what is the max separation? Is that like some real term? Polygon max separation. I've heard about colliding two bounding boxes by using this separating axis theorem. Let's read about this. Right. Jesus. Cookies. The separating axis theorem essentially states if you are able to draw a line to separate two polygons, they do not collide. I mean, sounds simple enough. If you have two convex polygons, right? But if you have a concave polygon, that doesn't work, right?
They disassociate themselves from their own actions, often experiencing hysterical blindness.
Right, it doesn't work if they are concave, right? Yes. The hyperplane separation theorem is a theorem about disjoint convex sets. Right, so is there any... Okay, how do I work with concave? Concave thingamajiggies. Right, so this does not apply. I wonder if someone is gonna mention how you do it for actually concave objects. Concave polygon collision protection. I should have just googled this earlier. There's definitely people who know about this, right? But if I'm looking at the box 2D, so they're using this separating axis theorem, it seems like, right? So does that mean that a polygon shape is always convex? Oh, yes. I should have read the fucking documentation, right? A solid convex polygon. A solid convex polygon, okay. It's so over. It's so over.
to resist aggressive impulses results in serious destructive acts. The people who commit these acts are in many ways no different from you and me, but they are no longer able to control their urges. They disassociate themselves from their own actions, often experiencing an hysterical blindness. They are blind to the darkness within themselves.
This formal system is based on polygons coverings by means of triangles in 2D and operations with signs. Based on polygons coverings, what does that even mean? So it sounds here like do you just collision detection is the interference or intersection determination between two moving objects. We can determine just whether collisions occurs or not, or else we can calculate features of the objects involved in the collision. The response to the collision may imply distortion or a change in the trajectory of the objects. Right. Right. At the first level, we deal with collision detection between two objects. Several. Okay, sure. That doesn't really matter, right? Right. Make a triangle's covering of the polygon with origin in the centroid of the figure. Wait. This is okay, because non-convex shapes can be represented by a combination of convex shapes. Yes, which... Okay, maybe it is just better than to like actually triangulate. What's happening here? Okay, okay, it's completely broken. However, right. So I'm okay, but I see so many more problems with that. Like there's still. There's still the question of like how do I actually resolve a collision, right? Maybe I can look at box 2D for that also, I guess. Let's see. So what does this where is the code? Right, collide polygons. Collide polygons. Like, how is this manifold actually used to like figure out where to move the polygon to, right, after a collision? That's my question. That is my question. Maybe that's just a flaw with how I do this, because I don't treat my player as like a single solid polygon, right? Maybe I have to do that in order for this to work properly. Maybe it's simpler in that case, actually. Maybe it's simpler. So if I... Oh shit, wrong code base. So if I go back to my individual triangle collision, right, and I enable the debug drawing of my triangles, right. Maybe that's the problem, I guess. Main problem is that I just handle every corner as some kind of separate thingy, right? Maybe that's just flawed from the start. Because the same... Yeah, well, I guess one simple thing that I could try maybe would be to right now, okay, so I collide every vertex against every triangle, right? And it kind of works in the cases where my triangles aren't like absolutely stretched to hell, right? Because of my triangulation algorithm. It does kind of work, except when I face through the floor, right? But maybe I can fix that. So the main problem here is that if I walk to the right here, what's essentially happening, right, is that I just move the player to the right, which means that I'm pushing the player into the ground, right? And the way I resolve, and that means, I guess, I check every single triangle. And right now, it's this elongated triangle that's being collided against. And if I find a collision with a triangle, I just push it out towards the edge of the triangle that is the closest to the point. But I can change that and just make it so that instead of that, we just push the point out towards like the player's center of mass or something like that. let's try that. That should solve, that is definitely gonna solve this case at least. But there might be more edge cases. So let's try that. So when we okay, so this, if we have a collision, which means that we have that some corner of the bounding box, right, is inside of some triangle. That's what this means. Right. So, if that is the case, we should push that point towards the center of mass. Right, so let's actually pull out that center of mass in some variable so that we can use that. That's going to be like, where do I get the corners? Right. Right, we have the corners, and also let's say okay, I think this right now we're looping through every triangle in the top level loop, right? And then we go through every corner. I think it should be the opposite, probably, but it probably doesn't matter. Yeah, actually, to simplify things, let me just let's test a single corner of the bounding box. Right, so this bottom left corner, right? Right, sure, makes sense. Okay, so we're checking one point, just to keep it simple. Yes, okay. So right here. What are we doing here? We check every edge of the triangle. And we do a plane distance check. So if this is positive, that means we are outside of the triangle. Okay, so this is inside, right? We count the number of intersections. Okay, let's just skip this. This makes wait, I'm even okay. Yeah, let's skip all of this. So the only thing we want to do here is check if we are inside of the triangle at all. Right? That's the only thing we are checking now. So we're checking every plane of the triangle. If we are behind all planes, all three planes, that means we are inside of the triangle, right? Okay. Which means we have a collision. Okay. Makes sense. And now if we have a collision, we need to figure out in which direction to push the player, right? And like just looking at this, like it's obvious to us, right? Which direction it should be pushed upwards, right? But how do we actually figure that out? So I think we want to take the center of mass of the player, basically. I think that should work in most cases, right? So let's say that we have the player center, which is going to be player position.x. Yeah, and that should be it. And y plus half of the size, because the player position, this pos, is at the feet of the player, right? And we can draw this point also to see if it makes sense. Debug draw it. something like that. Should be blue. Right, and for now, let's still oh shit. What happens if we just I just want to make the player not fall through the floor, just for testing. Okay, sure. I don't see the point, the debug point. Did I? Okay, what? X, Y, X, Y, X, Y, and the white. What? What happens? Yeah, that works, right? What? Am I completely... I mean, this shouldn't matter, right? I'm completely lost. Why? Why? X, Y, X, Y, X, Y. Oh shit, Jesus Christ, okay. I was assigning the Z, okay. Jesus Christ. Nice API, dude. Okay, but that is the center of the player, for sure. For sure, right? But why are we... Okay, for debugging, let's just remove gravity also, right? Then we can just walk into this wall, I guess. Stuff like that. Hell yeah, good tunes. Hell yeah. This mix is amazing. Amazing. Yeah, I can give you it. Let me, that should be the link, right? It's apparently, yeah, it's just one dude, one guy. All of it. It's insane. All right. So let's see. We now know if our corner is inside of a triangle. Okay, that's simple. Right, and now I think this should be pretty trivial. All I want to do... Okay, this is getting pretty convoluted. But we'll just go through every edge again of the triangle. And now I want to find well, I could just use like the normal, right? Well, let's just okay, let's whatever. So I guess we'll do the plane test again. So I want to check this. However, I don't want to check the corner, right? I want to check the... I want to check the center of mass. Or I could just check the... I can just check the normal. Okay, let's try that. So, let's do some hack right now. So, if the plane normal, okay, which is this. So if the normal is pointing up, let's try that. If the normal is pointing up, is that enough? Okay. Now let's check. Oh god, this is so... Okay, if the plane is pointing up, we should figure out how far inside of the plane we are, right? Which is the negative distance. Yeah. Oh god, and we store that here, right? So the max... This is getting really confusing, actually. This is getting really confusing. Graphics programming is much easier than this. So the push outs. Right. Wait, my plan doesn't work, I think. Well, how can it be this difficult? Wait. So box 2D. Box 2D. We find the max separation. Okay, and what does that mean? What does that mean? The max separation. The max separation. Okay, let's see what the max separating axis theorem. I mean, the separating axis theorem, it seems very simple. But what does the max separation mean? Max. So the max separation. Is the deepest point. So for every edge, we check every single vertex of the other shape and find the deepest point for that specific edge on the first polygon, and then we want the largest deepest point. So okay, I guess that makes sense. Right? We want the largest deepest point, which is the most shallow point. Right. Okay. Okay. What does that even tell us? Okay, so why do we want that? I guess that's right. I guess that does tell us, because if then I guess, wait, max separation. So that's minus. Okay, so if the max separation, I guess then, if the maximum of all deepest points is greater than 0, I guess that means we actually did find a separating line between these polygons, right? I guess that's how it's used, right? Well, it's checking the total radius, which what's the radius of a box? What's the radius of a box? What? What? The radius is a constant. the radius of the polygon shape skin. This should not be modified. Making this smaller means polygons will have an insufficient buffer for continuous collision. Linear slop. A small length used as a collision and constraint tolerance. Interesting. Interesting. Okay. So, okay, I mean, it's essentially 0, right? Okay, so I think it means what I think it means. Yeah, right. So we're checking this tolerance, epsilon, whatever, yada. But if it's above 0, essentially, right. That means, makes sense. If it's above 0, we found some line that separates these two convex shapes. Right, and that means there is no collision. That makes a lot of sense, and we do that for both of these shapes for some reason. Right. Sure. Okay, that makes sense. That makes sense. And is this separation actually used later? No, it's not. Okay. Well, what do we... Right, we get the... Right, we get the actual... We get the actual edge that is parallel to the separation line, right? For both of these polygons. Okay, okay. Makes sense so far. And then we use these edges. We only use one of them. Alright. And we pick the one that has a larger separation. Okay, sure. I don't know the implications of that, but let's see. Once we have this data and this XF, what is that? The transform. Okay, I can ignore those. I can ignore those in my case. Ignore those. Right, sure. So the incident edge. What is that? The incident edge. The incident edge. Ooh, okay, okay. Right, we transform the separation normal of the first shape into the second one. And what is the incident edge? the incident edge is the lowest dot product. And what does that mean? It means... Right, I guess it basically means it finds the... Wait, you're checking the normal. Okay, I thought it was checking the vertex. Okay, a dot... Okay, makes sense. Okay, checking the dot product of normals. So it's finding the lowest dot product, which means it's trying to find the normal that is the most parallel in the opposite direction, right? So it's trying to find the normal of the other shape that's pointing the most towards this edge. Okay. Okay. Right. So we're trying to find the edges that are basically looking at it at each other, right? Right. Okay. Right. So we have that index of shape 2. Right. Sure. Sure. And the clip vertices, what does that even mean? The clip vertices. The clip vertex. I hope there are some comments here. No. Used for computing contact manifolds. But what does it mean? Actually, a clip vertex. Let's see how it's used. I guess. So what do they actually store here? So they store the two vertices of the edge of shape 2. So we save the face, and the face is the face that is actually separating, well, not separating the two shapes, right? Right, but it's the closest one to any point on shape B. Okay, sure. Where is this type actually defined? It's not defined here, right? This incident edge, okay, it's not used here even. It's not used here. Clip segment to line. How does this make sense? Wait, hold up. If the points are behind the plane, that makes it seem like if both points are behind the plane, which okay, it's just wait, so what? Is it not possible that both are behind the plane? Okay, how, whatever. So what's actually happening with these clip points? Okay, I think I have got some kind of ideas, right? I think I got some ideas. From this. Let me see if this article actually goes through how to actually resolve some intersection, right? Because it's not just enough to know whether two shapes are colliding, right? I want to resolve the collision also to make it so that they're not intersecting, right? And how would I do that? Okay, so this article does not mention that, right? It only mentions the actual intersection part. Like, I wonder how far I have to go, right? Do I need a whole, like, physics engine, right? Or physics system? Or can I... Like, is there some simple version of that that I can solve, right? Without having to create some crazy physics... I don't know, yeah, physics system, right? So. like collision detection isn't really the problem, right? Or maybe it is like a, just like collision detection, that can be everything from like collision detection that feels like just figuring out whether a collision happens, right? And that's not really enough. Yeah. So collision detection, collision. What should I call it? Collision detection. Like, is it like rigid body dynamics, right? To the rigid body collision, maybe. This is sick. This is sick. Okay. Sick. Detect collisions. Like, I wonder how actually Box 2D would do this. So let's see. So we have this thingy-majingy, right, function that actually collides two polygons. However, in this scenario that I have, which is not working right now, but imagine that you have two shapes. Like, okay, the problem, I guess, is that sure, we can collide two polygons, but what happens if there are actually multiple intersections on the same polygon, which will happen in this case, right? Like if the player is walking to the right on this ground, then there will be multiple triangles that are actually intersecting or colliding with the player, right? And how do you find out which one you should actually care about, right? Which one do you care about? So we have this collide polygons, right? And this one outputs a manifold, right? So what happens with this manifold? B2 polygon contact, and is this yeah, that is an abstract. So is this, wait, so we have a B2 contact, and I assume that has an evaluate. Yes, evaluate virtual function. That's just perfect. Right, so where is this actually called? In B2 contact. Right. Update the contact manifold and touching status. So what is a B2 contact? The class manages contact between two shapes. A contact exists for each overlapping AABB in the broad face. Alright, makes a lot of sense. So a B2 contact is a potential overlap, right? They are a potential overlap. Okay, so I guess somewhere there is a list of these, right? So where are these actually? Is there like a constructor, or how do you actually initialize this? B2 contact, and it's not an abstract, right? The contact list. Right, which is in the B2 body. So each body has a contact list. Right, okay. So what happens with that? Destroying the contacts, destroying contacts, or do we actually use it anywhere? Delete contacts. Okay, dude. Okay. Is there like a getter for this, or wait? Contact list is a contact edge. Okay. Okay, so it has the contact. Okay. Okay. But like, does anybody else? Yeah. So someone else most likely accesses this, right? Is it the contact manager, maybe? All. Okay. Right, it's a linked list. Okay. Okay, so it's just checking a hash, right? So if the fixtures are different, yeah, this doesn't filter it out, right? All right. And there's a factory. Yes, a contact factory. Okay, so it doesn't seem like it's like actually resolving contacts here. Like, because somewhere, like, it has this list of contacts. Right? I'm right, so the world has a contact list also. Allegedly. Get contact list. Right, and what does that actually return? Okay, so it's the contact list in the contact manager, okay? Okay, sure. So I'm gonna assume that the contact manager does something with this, or like what? Right, okay. This is the top level collision call for the time step. Here all the narrow phase collision is processed for the world contact list. Okay, sounds good. Sounds very good. Right, we go through all contacts. Yeah, we get the info. They must be active. Sure. What the hell is this? We update. Okay, but it's like so we don't actually like do any we don't update the bodies in any way, right? All we do, right, is we like update. Okay, what does update mean? Update the contact manifold and touching status. Do not assume the fixture AABBs are overlapping or are valid. Okay. Okay. Okay, so there's no here. Like, is there a solver? Like contact solver? Sure. This has to be it, right? Like, where do we get the contacts from? Or is this like manifolds? Okay, M contacts. Okay, it's a double pointer situation. Alright, this is just a constructor. Constructor, where is the interesting part? Is there like a, okay, where are these like functions called, right? Where are they called? In the island. Okay, solve. This is probably the main interesting part, right? Integrate velocities. Right. For each body. What's H? The delta time, right? Makes sense. Sure. Solver data. Wait, what? Is this a bunch of different ones? Wait. Oh, wait. Joints. Okay, I don't care about that. Right, here's the contact solver. Right. So what is the count here? Wait. Right. Wait. Solver definition. Okay, right. The solver definition. So what is the count, actually? Jesus. Constructor. Count. Yeah, okay, this is the number of contacts. So this is the number of contacts in the whole entire world, right? Okay. Finally, okay. So what was that? We're solving. Yeah, solve velocity constraints. so it's just going through every single... wait, or is it? Every single contact, right? Every single contact. Okay, I think this is... I don't think I'm gonna get anything out of this reading it. I just wanted some idea on how multiple intersections of a single shape is handled, right? Okay, so I shouldn't have just completely butchered my current collision. I'm gonna bring that back, actually. What is this? Okay. Okay. Like so. Okay, now I have something good to work with, I think. Okay, so. So I just have to fix the push out, I think. Okay, so let's try to just fix the push out position, right? Instead of picking the closest edge, we want to pick one that's okay. I'm thinking really hard. Oh. how, like, it seems such a simple problem, right? In which direction should I push out the point that's inside of the triangle? Like, in which direction? Like, it seems obvious that it should be up, right? Or like which edge it should be, but what's the problem? Why can't I figure this out? Let me actually try something first. So how do I... Oh, no. I'm actually wondering, should I just... I should treat this player shape as a shape. Like, I think I need more information when I'm doing this collision testing, rather than just every corner individually, right? I think I need more information to work with. Because just testing a point against, like, the triangle doesn't know which direction is outwards, right? It doesn't know anything about the general shape that it's a part of, right? Yeah, well, specifically I'm trying to collide just this player box with the polygon that makes up my world, and yeah, and collision detection is not my wheelhouse, or physics engines or whatever. And it feels like a good idea to separate this polygon into triangles and just collide each triangle. But there are some obvious problems with that, at least the way I did it now. I mean, as you can see, yeah, I don't know how to resolve the collision, really. So I'm also wondering if I should collide against triangles at all. I mean, this collision that I have now, it like works in some cases, right? Except for, yeah, when it doesn't, right? I guess, like in this case, like it's just pushing my point towards the nearest edge of the triangle, which, I mean, doesn't make sense at all in the general case, right? But it works here. Not here. Yeah. And yeah, I was trying to... maybe that also works still. I was trying to actually not use the triangles for collision, and just use the polygon directly. And I feel like that does make sense. But it's also a lot more complicated, it seems like, because especially when it's a concave polygon, right? I found a bunch of articles that use this separating axis theorem, which makes sense for convex polygons, such as cubes or whatever. And this seems really simple, yeah. So, yeah, I think I should be using this separating axis theorem, probably, and using triangles separately. The only problem I guess I have is actually figuring out how to resolve the collision, right? Because it's trivial to like to check whether there is a collision at all, right? That's easy, and I have that working. But the problem is resolving that collision, right? I want to push out the player out of the ground and out of the walls, right? And my current approach is obviously not working. So yeah, I mean, okay, maybe I should just use triangles like that, and I just have to solve this kind of edge case, right? The only problem, really, with my code right now is how to resolve it. Okay, so I can focus on that, I guess. So I can easily find the collision, but then what to do is the question with that information. Okay, maybe I can just try it. Okay, so right now, I guess, if I am colliding with a triangle right now, let's see what I'm doing. If I'm doing that, right, in that case, right. Let's see. I'm checking every plane, and I choose the plane that is. Let's see. I choose the plane that is closest to the point. But I want one more condition here, I think. Okay. So in this case, I don't... Let me think. Right. I want to somehow... Okay, let's use the center of the player. Right. Player center. Again, I removed it before because I'm just a bit I'm jumping around between stuff so much, but let's try this. Okay, I think if I just solve the collision resolution, everything should be fine. So let's try that. Right, so let's say if my yeah. Yeah, let's say, okay, so this let's just try, right? Okay, if I am colliding with a triangle, then let's just say that I push it out towards the closest edge that is also looking at the center of the player. Let's try that, because, okay, let's try that. Whatever. So instead, right now I only have this condition, which in essence, yeah, this finds the closest edge. So let's add another condition here, actually. That checks, yeah, the player center. Yeah. And it has to look at the player center, which means that this should be greater than 0. Right. Let's see what happens. I actually wonder what happens if I guess I can assert that, like assert that this is not negative max. Right. Okay, that fails immediately. Oi. Right, of course. Like that. Okay, it kind of fixes it when I'm walking here, but the problem here, I guess, is that I walk, so I move the player to the right, which means that I'm basically pushing this corner point. I'm pushing it below this triangle. Right, so this triangle never gets intersected. Right, so I probably, yeah, I have to treat this this player as like some kind of thing, right? Some unified thing instead of set of points. Okay, but how should I do that? I mean, I looked at box 2D a bit. I'm not 100% sure. Okay, so this case is like kinda solved. Not really. I mean, if I okay, this case is solved. Sure, but okay, so what if I walk to the left? Yeah, no. It's just completely unreliable still. Yeah, in this case also fails. Like right. I mean, I guess I just need to collide polygons with each other. Right? That's the only solution to this. Right. But like, how to actually do that? Right? How to actually do that? So what did box 2D actually try to do? They try to find. They use the separating axis theorem. Yeah, on both polygons. Yeah, I mean, I guess I can start there. Right, I can start there. And I guess it makes things easy, actually, if you do abstract the player shape as a polygon. Like, have these be the same data types, essentially. Right, but I think I have to start there. So we have two polygons and we want to check the separating axis theorem. And like on each other, because what I'm missing right now is the places, yeah, here. Like, the player can't just be a set of points. Because this collision, or for example here, if I walk left here, like, this point never touches this triangle, right? So the only triangle that my point knows is this one, right? Yeah, is this bottom one, right? However, if I actually do the separating axis theorem thingy on all triangles versus my player polygon, let's say, then I will find these as well. And it's basically, I mean, it's the same. If I treated, well, let's try to. So if I add back this, where I actually test collision against all vertices of my player box, right? Like, there is still this problem, like here, right? This, yeah, okay. I think that's like, if I start there, I think I might figure something out. Right, because if I do the separating axis thingy-majingy, I will check every vertex. Right. Right now I can't stand, like, yeah, okay. Let's try that, I guess. I don't have a clear plan, but I don't have a clear plan at all. Right. So I actually want to read box 2D, but only the like collision detection part, right? B2 collide polygons, right? So they find the max separation, right? I read this already. So right, find the deepest point. Okay, makes sense. Let's try. Let's try. So I think a first good thing actually would be to disable gravity, and also, let's see, just to try make it possible to debug this in an easy way. So why, let's do that. Okay, so now I can move around easily, and it should be simple to, like, if I don't do any collision resolving, right? If I don't do any collision resolving, it should be nice. Well, let's see. Yeah, so I can just like debug draws, the intersection stuff now, stuff like that without, yeah, it's gonna be nice. Okay, so what's the first step? I guess we want to basically well, I guess we want to define yeah, we don't have to define any like plane, right? No, so let's do well. The nice thing about representing the triangle and the player box as with the same data, right? Because I basically want to do the same check twice, right? But just with the models or with the shapes flipped. So let's do that actually. So we have something like let's say Let's click collision polygon. Right, and this polygon has some number of positions, right? Right, positions and normals, right? And we should have some kind of count or size. Let's call it size, right? So for the player shape, this will be 4, right? And for the triangle, this will be 3, obviously. All right. Right. So, and then let's see. Actually, let's look at this. Okay, so the max separation. Right, the max separation is gonna return the max separation. Find max separation. Right, so we have polygon A and polygon B. Right. And we're gonna initialize the max separation to, like, is it negative float max, right? Because it's gonna be. That's actually I'm gonna cheat a bit and look at box 2D. Right, yeah, makes sense. Actually, what is the license? It's the MIT license. I assume I can just look at this. Right. Right. And the best index is, like, I mean, so the max separation and the max. Yeah, let's see, index. Right. Sure. Why not? Right. And then for every for every edge, which is that's the same as the number of vertices, right? Yes, right. So I let's say so we go through every edge of shape of polygon A. What's the problem here? Collision polygon has no field size. That's just wrong. Right, and this is just simpler than box 2D in every single way, right? I don't have transforms, right? I can't rotate my player bounding box, right? All right, so we go through every edge of shape A, and we get some kind of normal. Is IntelliSense just slow, or what's happening? Did I write some bad code? Or... Okay, actually, let's try to initialize this this shape, right? So we want to go in a clockwise direction, right? Are we doing that right now? No. So this would be the top, wait. Yeah, top left, top right, bottom right, bottom left. Yeah. So those are the corners, right? So the player normals, and I think we can. No, let's just do that in a loop, actually. So we have to figure out the normals. Well, we don't have... I'm stupid. Okay, we don't have to figure out the normals. We just put them here, right? Okay. So this is the top, essentially, right? So we're going from top left to top right. That means the normal is pointing up, right? That's the top, right. And then from top right to bottom right, that's gonna be pointing to the right, and to the right edge, right? And then we have the bottom pointing down, and we have the pointing left. Those are the normals of the player shape, right? And then we have this polygon, right? So we have the player polygon, which we can then just initialize these fields. So the pos is the player, let's call it player corners, right? And we have the normal, which is the player normals, like that. Okay, perfect. Right, and then we want to go through, yeah, instead of this corner bullshit, right? Right, we just go through every triangle instead. Triangle index. Right, and we have this like, yeah, word collision, triangle count. Perfect. Let's do this. Right, and we need to do a lot of the same things. We want to figure out the normal of each edge of this triangle, right? And that is... That's like this. Right, and what we want to figure out here is the, I guess, triangle normals. basically, yeah. We will have 3 of those, because there are 3 edges. And these planes, I guess that's essentially it, right. Normal. Let's just try that, and then we can define this polygon type also for the triangle now. So we will have the triangle polygon, which has 3 edges. Right, and we will have the let's see here. So the triangle collider, that's a I should be able to just take the address of that, right? So the position is going to be the this, right? And I guess can we do static assert? I think we can. Size of this one should be that should be 8 1624, right? Right. And the normals is going to be the triangle normals. Right, okay. So now we have defined our 2 things, the player and each triangle in the scene, as 2 like with the same data, right? So now we can call this function. And the reason we need this in the same data is that now we can just have the player polygon. And the triangle polygon. Let's call this separation A and B. Right. Now we can just do these 2 tests with the same function, right? So right, and from this we also want to know. So we're testing A against B. So we want to know which edge of polygon A is the, I guess, yeah, what will it be? They call it the best index. What we're looking for I guess essentially it's the one that has the largest separation. So I guess essentially it's the edge that is, I guess it's gonna be the closest one, right, to the other polygon, basically. Oh no, I closed the wrong. No. I want this up for a reference, as a reference. Right. And we're right. We have the edge of polygon A, and we'll check every vertex of polygon B. And what is this exact? Right, sure. Well, it's a normal Right. So we have the position A and normal A. Right. Deepest distance, I guess. Right, and the max index is going to be the index A, right? And we want and it is probably a good idea to have some epsilon, right? Just like box 2D. So if the separation, do we have to check this separately? No, not really, right? Okay. Let's make it pretty big just to see, I guess. Right. So let's call that collision epsilon. Okay, 0.1 is a bit much, actually, but like that. Like, right, so if we find a separation, a line that can separate these two polygons, right? That means we do not have a collision and we don't have to bother, right? Makes a lot of sense. Right. So, otherwise, let us add some debug drawing. So if we if we do not have a separation, I guess, then let's debug this then. So let's see. So the separation index A is the player polygon. So let's just debug it, draw that, I guess. So we have the edge index, which is the vertex index. So let's do something like are we using A and B already? No. Okay. So we'll get the vertex position from the player using this, and we get the next one like that. Like that. Let's just draw a line between these 2 points to see if we're getting any reasonable results.
We trust each other.
Right. I'm already debug drawing these lines, so that's not gonna show up, right? That's a bit annoying, right? And I can't just
We trust each other.
let's at least disable the drawing of the collision triangles, I guess. And then we won't see anything, obviously, because I have to add the drawing of those as well. So let's also do that. So instead of the player polygon, we look at the triangle polygon, right? And we take the separation index B and see if we get anything. Yes. We do. That seems kinda reasonable, actually.
We trust each other.
That's actually a lot better than I was able to come up with. But that's only half of the problem, I guess. Actually, where am I drawing the player? What? Where is this player coming from? Well, it has to be in the game somewhere, right? This is... Okay, draw debug box. Okay, I apparently have a debug box abstraction. Okay. Okay, actually something I want to basically, let's see, debug, debug HLSL. HLSL, so, oh, I guess that's in the pipeline state, right? I want to increase the line width, so I guess that's in the pipeline here. Line width, yeah, let's increase that so it's easier to see like this debug drawing stuff. Okay, that's more like it. Okay, let's change color. So let's draw the player as blue, maybe, just to distinguish them. Right. So now the question is, how do I actually resolve these collisions now? And some of these look pretty questionable, actually. Well, okay, let's see. Let's see. Find incident edge. That's where the magic happens. So we once again go through every edge of the other shape. However, I want to understand what this is effectively doing. So we choose like I guess polygon 1, let's see. So we basically choose one of the polygons as, I guess, more important, right? Like, so the one that has the greatest separation gets singled out. And what does that mean? To have the greatest separation. What does that mean? I guess it means okay, so when we test, I guess, when we test the player, we check every vertex of each triangle, right? Yeah. And the greatest separation? So if we are picking the greatest separation, yeah, what does that mean in reality, right? I'm trying to conceptualize it in my head a bit. So let's say we have this collision, for example. Which one of these would be selected to have the greatest separation? It will probably be the triangle, right? Yeah. And in this case, it will probably be the player, right? So we're basically picking. I guess that would be like the shape that is actually pushing out the other one, in a sense. Or okay, we'll see what happens. Okay, so we have selected the shape. So polygon 1 is the shape, is the polygon that has the greatest separation. So I guess where the other polygon has the shallowest intersection, I guess, basically. Right. So what is the incident edge then? Okay, so we do pass both polygons. I missed that. Okay, so polygon 1, and we have edge 1, right? So okay, let's just, I guess, try this to find the incident edge. And right, I think I guess we'll if we like, okay, I guess we'll find out what the incident edge is, right? We'll find out if we just keep debug drawing this stuff, right? Okay, so there is something known as an incident edge, right? And we will find it. Okay, but first we should pick the shape with the largest separation. Right. So if the separation in polygon B is greater than in A, I can try to keep the names somewhat consistent, right? So we have this. So it's poly. Like reference polygon. Actually wonder, like reference polygon. Reference polygon. Yeah, I really wonder what this is about, like the incident. But we will figure out. Okay, sure. Flip. Okay, for now, let's just care about that, right? Yeah, right, and reference, okay. So, this would be the collision polygon, right? Transforms, we do not care. Right, so B. If the separation B is larger and B is basically the triangle polygon, right? Yeah. It's like that. And otherwise, it's swapped. Like that, yeah, HB. Okay, so this actually matters, right? A manifold, blah blah blah. Right. The local point usage. Right, and we can probably simplify this later, right? I just wanna get it somewhat similar, right? And we can do some debug drawing and figure this out. Right. So now we have this. Now we can actually find the incident edge. Like, okay, I guess this clipping is important. Sure, but nothing is actually being done with this. Like, is this the only output? Right? This is the only output. The clip vertices. Right, nothing else is being modified. So why are we doing it here, even? Oh, whatever. So, okay, so what's happening here, then? Alright, it's computing some stuff that's needed for the clipping, right? This looks very similar to what I was doing before. Taking the tangent dot product. And I guess this is the... Right, okay, it's not the center, right? Oh well. So I'm wondering if we can... if we can debug draw this in some kind of useful way anyway. So what are we actually outputting here? We are outputting... Yeah, the incidents, right? So I guess we... Right, I mean, it seems like an edge 1 here, that's the same, right? Yeah, that's the same. So the only thing we want is the clip indices, and I mean this is just the index, right? Okay, so for now, let's just do something like this. And this function cannot fail, right? No. Find incident edge. Right, so the output of this will be the incident edge, right? And we have polygon A and B, right? And we have, yeah, well, let's call it edge A, right? Right, so all we're doing okay, I think this makes a lot of sense. Right. We want to find the edge on the other polygon that's like basically most perpendicular, right? Right. That makes sense. We want to find the most perpendicular. Yeah. Right. Right. So for each edge in the other polygon, yeah, check the dot product. Right, normal A. Yeah. That's it, right? Right, and all we have to output here as the incident edge is the min index now, right? That's it, because I mean this is, yeah, this is just, but I mean they have some more kind of like they need some more abstract or whatever, like more general data type for this, right? But all we need is this index, right? That's good. That's good. So let's call this now, I guess. Let's call this. So we have the right. So we'll call it the incident edge. Sure, and we get that back out, right? So we have the poly 1 and the edge 1. Poly 2. I should have called these 1 and 2 maybe. Whatever. Let's see. Let's see. I want to check if this makes sense. Like, wait, is the polygon? Yeah, I mean the only thing that's used here is the norm, right? I don't really have to pass. I don't really have to pass the polygon at all. But let's do that for now. Let's do it. Right. So now I could actually. Yeah, let's debug draw this then. So we have the right, we have the incident edge. So let's debug draw that. And this incident edge is the edge on. Wait. Well, right, it's okay, it's 2 vertices, right? Okay, so let's debug draw that as 2 vertices, right? So do draw debug point. Draw debug point. And okay, so poly 1, no, poly 2 is the one we want to check. Right. So the incident edge, like so. Right. And B is the same, right? But the next one. Right. So I put 2 sides, wrap that around. Right. So let's draw these 2. Let's make them red. Okay. So what should these actually be used for then? Alright, and my mental model was correct here. That Right. Yeah, now the question is... Okay, so we have this incident edge, right? what do we do with this? What do we do with this? Like, I guess looking at these cases also don't make sense, right? Because you basically you want to catch the collision when it's actually on the edge, right? But okay. Right, so we have this incident edge. Now what? Now what? Now what? Okay, so we clip it. So is that really that important, right? And we have this manifold which so I guess sure we want to clip them, but like a manifold point is a contact point belonging to a contact manifold. It holds details related to the geometry and dynamics of the contact points. The local point usage depends on the manifold type. A manifold for two touching convex shapes. Clip point versus plane with radius. What's a clip point? I mean, let me try to, like, so what would... okay. The points of contact. So is that all? So like, okay, and then what? And then what? And then what? What do we actually do with the contact points then later? What do we do with the contact points? copying the old impulses. MP1 is the old manifold. I mean, sure. So it doesn't do anything with this manifold except for, I guess, storing it for later, I guess. I guess. It's really hard to read this flow, right? Maybe actually. Maybe box 2D light has something similar, right? Even though it's just boxes. Let's see what this does. Also computes an incident edge, yeah. So we have this collide. Right, so wait, this num, okay, it returns the number of contacts, of course, right? Of course. So what do we do with the contacts? Accumulated normal impulse. Okay, now we're getting somewhere. So we have the contacts. Yeah. Oh. There's probably something I can learn from looking at this, right? But like using this, I think it should definitely be possible to resolve the collision without some like complete physics solver, right? But I'm not sure. Yeah, we'll see. I mean, because the world is static, you know, the player is not, and it's not like the player isn't really a physics object either, right? Well, in some ways, right? Sure, but it can be very simple, just if I figure out how to actually do it. But I'm extremely tired right now, so I'm not gonna get anything done, at least this stream, right? Kinda a boring stream today, but actually, do I have? Yeah, I still have the. I have the old. Oops. Wrong terminal. Let's see. I still have the old implementation still, though. So. But I kinda. I mean, really no progress at all, right, today, except for reading some stuff, looking at code. Yeah. Now that I'm actually playing this, do I really have to change that? Yeah, well, but yeah, whatever. It's we'll figure it out. Yeah, let's see. I guess I should commit anyway. Right, I did some very cursed sleeping function. But let's call that, I guess, player. Well, let's polygon. Well, player collision rework whip. Sure. And I have to sleep. Holy hell. See you later.